Hello, sixth graders. Welcome to sixth grade math writing expressions lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is, I can write an algebraic expression by completing practice problems with 100% accuracy in multiple attempts. Today's standard is to write, read, and evaluate expressions in which letters stand for numbers. We're going to start today's lesson by looking at some key words and phrases that imply math operations. So when I say that they imply math operations, what I mean is that they usually mean these operations, but not always. There are some exceptions to these rules, so be careful. So there is a page in your math notebook, and you need to record these words in the table on that page. And so for addition, if you see the words added to, plus, sum of, more than, increased by, total of, or and, then you are going to think, oh, I might be wanting to add those things. And then write the words that mean subtraction under the subtraction heading, and multiplication and division. So go ahead and pause this and take a couple of minutes and write those words in your math notebook. Now we'll take a look at example 1, writing numerical expressions. So it says, write the phrase as an expression. Letter A is 8 fewer than 21. So while you might look back at your chart and see that fewer than is under subtraction, you're correct. You need to be sure you get this in the correct order. So you can't have 8 fewer than 21 if you put the 8 first. You have to put the 21 first. So the phrase 8 fewer than 21 does mean subtraction, but subtraction is a funny thing, and sometimes you have to turn the numbers around. So it's 21 minus 8. So be careful with that one. And be careful whenever you have subtraction or division that you get things in the correct order. Letter B, the product of 30 and 9. So the word product means you're going to be multiplying. So that means that you're going to write 30 times 9 with an X, or 30 times 9 with a dot. Example 2 says, we are still writing algebraic expressions, and we have an A, a B, and a C. So letter A is 14 more than a number X. So we're going to write the X down first, and then we're going to add 14 to that. So more than means we're adding. And then letter B says a number Y minus 75. So in this instance, since it's just Y minus 75, you're going to keep everything in the same order that it is in the sentence. Letter C, the quotient of 3 and a number Z. Quotient always means division, or usually means division. And so you want to keep things in the same order that they're in the sentence. Let's take a look at this common error over here, because that's what I've been hinting at. It says, when writing expressions involving subtraction or division, order is important. For example, the quotient of a number X and 2 means X divided by 2, not 2 divided by X. Example 3, we're still writing an algebraic expression. We just have a lot more information. So it says the length of Interstate 90 from the west coast to the east coast is 153.5 miles more than 2 times the length of Interstate 15 from Southern California to northern Montana. That's a lot of information. Let M be the length of Interstate 15. Which expression can you use to interpret the length of Interstate 90? So let's kind of skip our answers here because they're a little bit confusing, and go down here to the explanation. So it says the word times means multiplication. So when it says that I-90 is 153.5 miles more than 2 times Interstate 15. So that means you're multiplying it by 2. So M is the length of Interstate 15. So 2M is the 2 times part of that. And then it says the phrase more than means addition. So 2M and 153.5. So we're adding those because it says it's 153.5 more than, so think plus, and 2 times, so think multiplication. I'm just going to write those big signs right there in our problem. And so we're taking the length of Interstate 15, which is M, I assume that's for miles, multiplying it by 2, and adding 153.5 to find the length of Interstate 90. And so the correct answer is A. Example 4, pardon the jaggedy edges on here. I was trying to cut it out without you seeing all the stuff you didn't need to see. So it's our real life application. You plant a cypress tree that is 10 inches tall. Each year, its height increases by 15 inches. So it starts at 10 inches. So remember, it doesn't start at 0, it starts at 10 inches. Make a table that shows the height of the tree for 4 years. Then write an expression for the height after T years. What is the height after 9 years? So the height is increasing, so you're adding 15 each year as shown on the table. So when T, time, is 0, the height is 10 inches because it starts at 10 inches. And so it's always 10, and then it grows for 15 inches. So you start with 10 inches, and then it grows 15 inches times the number of years that you have it. So you can see that an expression is 10 plus 15 times T, which is the number of years that you have it. So the height after year T is 10 plus 15T. And then we're evaluating that for when T equals 9. So if you have the tree for 9 years, you substitute in a 9 for T, and you multiply 15 times 9, and you add that to 10, and you get that the tree is 145 inches tall. And then here's a good little study tip over here. It says sometimes, like in example 3, a variable represents one single value. Other times, like in example 4, a variable can represent more than one value. So that means that sometimes the variable changes within the problem, and sometimes it just changes and it's something that might be the same and might be something that you are actually trying to solve for. Here's what you need to do next to finish this lesson. You need to be sure your notes are complete in your ISN, complete your Google Form questions, review your lesson if you need to, and complete your Big Ideas math assignment in your Math Spiral notebook. Be sure you submit that when it is 100% correct, not before, and track your progress on your playlist.